Hi guys, today we're going to take a look at factoring. Now there's a lot of different strategies that we have to be able to factor a polynomial. What we're going to take a look at is strategies that apply to four-term polynomials or three-term polynomials. So today we're going to look at grouping, and then we're also going to use a strategy called the AC method to factor those three-term polynomials. Now, one thing I want you to remember is that the first step for factoring anything, no matter how many terms it has, no matter what strategy you're going to use, is to start by factoring out a GCF, a greatest common factor. So if you can divide all of your terms by x or by 2 or by 7, make sure you do that before applying any of the strategies that we look at for today. So we're going to start by talking about grouping. So this is a strategy we can use when we have four terms. Grouping is exactly what it sounds like. We're going to take our big polynomial and split it up into groups, okay? So here's an example of what that looks like. So we have our four-term polynomial and we've split it up into groups, okay? So we're always going to split up into the first two terms and then the last two terms. So that's what we've done here. And then out of each group, we're going to find the GCF, the greatest common factor. What do those terms have in common? And we're going to factor it out of each term. So if I take a look at this first group, they each have x's. Okay? And in fact, each of them could be evenly divided by x squared. So I'm going to go ahead and factor x squared out the same way you would factor out a GCF. Okay, a greatest common factor. So when I divide that x squared out of the first term, I'm left with x. And then out of the second term, I'm left with minus 3. Then we do the same thing for our second term. Notice that each of these pieces of my second term, each part here, is divisible by 2. So that's what we're going to pull out of each of these pieces. I'm going to divide that first term by 2 and divide the last part by 2. So when I factor out that 2, I'm left with x minus 3. Now, when you're factoring by grouping, this stuff in parentheses should always be the same. If it's not, you need to go back and double check that you actually did pull out the whole GCF and that you divided it out of those terms correctly. So what you should get every time you factor by grouping is that these guys are the same. Okay, that's what we want to see. Because when these guys are the same, we can now treat this again like a GCF. I have this as a factor of the first term, and I have it again as a factor of the second term. So it doesn't matter what it is. I could actually just call it a big purple blob, right? I have purple blob as part of both of these terms, so I can factor out purple blob like a GCF, right? Here's purple blob, and then write what's left over, just like we did here. So we factored out x squared as a GCF and wrote what was left over. We factored out 2 as a GCF and wrote what was left over. Now we factor out this thing in parentheses as a GCF and write what's left over. So left over, I would have x squared plus 2. Okay, and that's our factored polynomial. So that's the first thing we're going to look at. So we're going to take an example, or we're going to take a look at a few examples of factoring by grouping. Remember, we're always going to start by looking for a greatest common factor, a GCF. So if I take a look at my first example, I don't see a GCF here, okay? I don't see x as part of every term. I can't divide them all by 2 or 3 or 4 or 6. So no GCFs here, so we're going to hop straight to that grouping. So here's my first group, and here's my second group. And then I'm going to look for GCFs in each of those groups. So for this first group, I've got x as part of both of those terms, and both of these coefficients are divisible by 3. So my GCF here is going to be 3x. I'm going to factor that out of each part here of my first group and then write what's left over. So 6 divided by 3 would leave me with 2. X squared, if I divide out that x or factor out that x, leaves me with x. And then plus 3 divided by 3 would be 1. And x divided by x, again, just 1. So technically I could write 1 times 1 here, but that would still just give me 1. So that's my first group factored. Now let's look at our second group. 4x and 2 are both divisible by 2. So that would be my GCF there. So I'm going to divide out a positive 2. So when I factor out or divide out that positive 2, I would be left with 2x plus 2 divided by 2 would be 1. Notice my stuff in parentheses is the same. So now I get to pull that thing out as my GCF. So that stuff in parentheses is my GCF, that 2x plus 1. And left over, when I factor 2x plus 1 out of here, I'm left with 3x. And when I factor 2x plus 1 out of the second term, I'm left with a positive 2. So that is now factored using that grouping method. Let's take a look at another example. So for our next example, notice here that we actually have all even coefficients, and our constant term is also even. So we can actually factor out a 2 from each of these. I'm going to go ahead and start by pulling out my GCF of 2 from all of these terms. That would give me x cubed minus 3x squared plus 1x minus 3. Okay. Always pull out GCFs first. From here, I'm going to split this up into groups. So first 2 terms and last 2 terms, and then look for GCFs in each of those groups. In my first group, both of these have x, and in fact, I can pull out as many as 2 x's and x squared out of each of these terms. So my GCF here would be x squared. That would leave me with x minus 3, because that x squared, take out x squared, would just be 1. And then in our second group, we've got 1x minus 3. In this second group, we actually don't really have what I would call an interesting GCF that we can pull out. So instead, what we're going to pull out is the only GCF we have, which is just a 1. So I'm going to factor out a positive 1 as my GCF here. That probably seems kind of silly, but anytime I'm factoring by grouping, I need to pull something out as a GCF. If I don't have anything exciting I can pull out, then we're just going to pull out a 1. So that would leave me with x, or 1x if you prefer, x minus 3. Now notice that our stuff in parentheses is the same again. So we can pull that stuff in parentheses out front as our GCF, and then look at what's left over. So for the second term, when I factor out that x minus 3, I'm left with x squared. And then for the second term, when I pull out that x minus 3, I'm left with plus 1. Okay. And that's our factored polynomial. Now, later on, we'll talk about factoring completely using our rational numbers as best we can. So later on, we'll talk about if I still have an x squared, can I keep factoring or not? And in some cases, the answer is yes. And in some cases, for our purposes, it'll be actually, we're going to leave it there for right now. For today, we're just going to leave that right as it is. So after I've factored by grouping and I've got factor times factor, we'll stop. Okay, so for this one, we'll stop for right now. Let's take a look at one more of these grouping problems. So let's take a look at our next example right here. Same idea. I'm going to start by splitting this up into groups. I don't have a GCF for all of these terms. Remember, greatest common factor means it's common to all terms. So 3 of them have an x. 3 of them are divisible by 2, but not all of them. So no GCF pull up. So let's put this up into our groups there. Okay. And then look for your GCF for each group. So for this first group, we can factor out an x squared. They have that in common, so we'll pull that out. That would leave me with x plus 4. For our second group, our coefficients and our constant term are both even, so we can divide both of those by 2, a positive 2. That would leave me with x plus 4 when I divide out that 2 or factor out that 2. Now my stuff in parentheses is the same again. So I get to pull that out as my new GCF, my new common factor, right? And it's fair to call this thing a factor because I'm multiplying these guys. So when I talk about common factors, remember factor means things that are being multiplied together. So this is being multiplied by something in each of these terms. That means that if it's the same in both, it's a common factor to each of these, which is why I can pull it out. And then left over, once I factor out that x plus 4 from this first term, I would have x squared. And in my second term, when I factor out that x plus 4, I would have plus 2 left. Okay, so that's factoring by grouping. And this is the strategy that we're actually going to use for our AC method for factoring trinomials. So on the next page, on page 27, we're going to talk about something called the AC method. And that lets us factor these polynomials that have 3 terms, okay, what we call trinomials. Tricycle 3, trinomial 3, okay? So here's how the AC method works. We start by identifying our lead coefficient and our constant term, and we multiply them together. So that's what we're seeing here. 2 is our lead coefficient, 3 is our constant term. We multiply them together. So for this problem, we would get 6 when we multiply 2 and 3. Now what we're going to do is take this guy, this product that we have here, and we're going to find a way to factor it so that we could add those factors together to get our B, our middle coefficient, okay? So find factors of this number that add to the middle term's coefficient. So you may need to make yourself a little list off to the side. I have to do that a lot. So what times what would give me 6? Well, 1 times 6, or -1 times -6, or 2 times 3, or -2 times -3. And out of my list of factors of 6, I want to pick the pair that would add to give me 7. So if I change this to a plus sign instead, which of these would give me 7? Well, that would be this first one. 1 times 6 gives me 6. 1 plus 6 gives me 7. So those are the factors of 6 that I'm going to end up using. So what do I do with these factors of 6? I actually use them to rewrite this middle term, okay? So instead of keeping 7x, I'm actually going to split that up using the factors that I picked here. So instead of 7x, I'm going to just rewrite that as 1x plus 6x. This is okay to do because I haven't actually changed the problem. If I were to combine these like terms here, I would get back to 7x, which is what we started with. Okay, so I'm rewriting this, but I haven't changed it at all. The idea is that we rewrite this problem so that it has 4 terms. Okay, why do we want to rewrite it with 4 terms? Because we know how to factor something that has 4 terms. If I have 4 terms, I can use my grouping method. So that's really the goal here with AC method, is to take something with 3 terms and rewrite it so that it has 4 terms, because we know how to factor stuff that has 4 terms. So the next thing I'm going to do, now that I have this 4-term polynomial, is split it up into groups and factor by grouping. So that's what we see here. We split our polynomial up into groups. My GCF here would be x. Left over, I would have 2x plus 1, which we see here, x times 2x plus 1. My GCF here would be 3, a positive 3. That would give me 2x plus 1. Again, we see that here. My stuff in parentheses is the same, so I get to pull that out as my GCF and write what's left over. Okay, so the idea here is we figure out how can I rewrite this 3-term thing so that it looks like a 4-term thing, and then factor by grouping. So let's take a look at a couple of examples. For our first example here, we have 2x squared plus 6x minus 20. Notice that all of my coefficients and my constant term are even numbers. Remember, we still start by pulling out any greatest common factor we may have. So here, we actually have a GCF of 2 that we need to pull out before we do anything else. So if I factor 2 out of every term, I would have x squared plus 3x minus 10. And we'll use our AC method from here. So our A, or lead coefficient, since I remember it's not 2, we pulled that out as a GCF. If I don't see it, remember that it's 1. So here's our lead coefficient. And here's our constant term called the AC method, because if I were to write this, ax squared plus bx plus c, my standard trinomial form, we're identifying that a and that c, right? The lead coefficient and the constant term. So once I've identified them, I'm gonna multiply them together. So 1 times -10 would give me -10. And then I'm gonna look for factors of -10 that would add to 3. So I'm gonna make a little list here. You may find that as you work through more of these problems, you don't need to make a list. Um, I like to make a list. So that would be 1 times 10. One of those needs to be negative to get me -10, or 1 times -10, or we could have -2 times 5, or 2 times -5. And then I'm out of factors, right? I like to make my list starting with 1 and going in order. That way I don't miss anything. And then if I were to keep going, my next thing would be 5. I already have the 5 factors written over here. So I know that's my whole list. And now I want which pair out of this list would add to 3, positive 3. So that's going to be -2 and 5. That means I'm going to rewrite this middle term with -2 and 5. So we have this GCF of 2 that's going to hang out in front. I'm going to focus on this stuff in parentheses for right now, and we'll see that -2 GCF sort of at the end. So if I rewrite this, I would have x squared minus 2x plus 5x minus 10. And again, we still have that GCF of 2 just hanging out in front for right now. Now that I have 4 terms, I'm going to split this up into groups and use our grouping strategy. So my GCF for this first group would be x, so I'm going to pull that out. Left over, I would have x minus 2. For my second group, the GCF would be a positive 5. And left over, I would have x -10 divided by 5 minus 2. Again, still with that 2 just hanging out in front there. My stuff in parentheses is the same, so that's my new GCF to pull out. So I would have x minus 2 as my GCF. That would leave me with x plus 5. And again, we still have that GCF of 2 hanging out in front there. Okay, so that would be my factored form of this function. Let's take a look at another example. For our next example, no GCF here to pull out at the start, so we're going to hop straight to identifying our lead coefficient and our constant term. That would be 2 and 3. I'm going to multiply them together. 2 times 3 gives me 6. Factors of 6 that add to 7. This problem should look familiar, right, you guys? That's the one that we looked at up here. So just as a little refresher, factors of 6 that would add to 7. Well, if I start writing my list, the first one I'm going to write is 1 and 6. That's actually the pair that I need, right? So I would rewrite this as 2x squared plus 1x plus 6x plus 3. And I'm going to show you something here. The middle terms, the order of those is actually not important. So let's say I wrote this as 6 times 1 instead. If I put that in my problem as 6x times 1x, this will still work. So we know what we got by putting the 1x first and then the 6x. So let's try it the other way for this one. So I would have my groups here, right? This is a 6 and this is a 1, really big one, but it's a 1. GCF for this first group would be 2x. So I would have x plus 3. 6x divided by 2x would give me 3. For my second group, again, this is a problem where we don't have any interesting GCFs to pull out, but we have to pull out something. So we're going to pull out 1, okay, positive 1. That would leave me with x plus 3. So this sort of middle step here looks different than what we had the first time around. That's okay. My stuff in parentheses is still the same, which is what I need to happen. So I can still pull that out as my GCF for this next step. And then I'm left with 2x plus 1. So my factored form for this function would be x plus 3 times 2x plus 1. I have the same factors from my original problem, just in a different order. Okay, if we were to distribute back, we would get exactly the same thing. So same idea here. Let's take a look at another example. Let's take a look at this problem right below. So 3x squared minus 17x plus 10. Since we have three terms, we're going to use that AC method. So lead coefficient times that constant term, 3 times 10 will give me 30. And now I want factors of 30 that will add to negative 17. Okay, so I'm going to start writing my list. 1 times 30, negative 1 times negative 30. And again, I always go in order so I don't miss stuff. 2 times 15, or negative 2 times negative 15. I would also have 3 times 10, or negative 3 times negative 10. And actually, I'm going to go ahead and stop because we already have the factor pair that we need. We want to add to negative 17. That would be negative 2 and negative 15. Okay? So I'm going to rewrite this as 3x squared minus 2x minus 15x plus 10. And then we'll split this up into our groups. So first two terms and last two terms. And then the GCF for my first two terms, 3x squared minus 2x, that's just going to be x. Left over then, when I factor out that x, I would have 3x minus 2. For my second group, notice that our first term in the second group is negative, so we're going to have to be careful with our signs here. So I've got negative 15x plus 10x. 15, negative 15 and 10 would have a common factor of 5. Since this starts as a negative, I'm going to factor out a negative 5. Okay. So negative 15x divided by negative 5 gives me 3x, positive 3x. If I hadn't pulled out that negative, I would have a negative inside my parentheses here. My signs would be wrong in this second group, okay? And that would be a problem. So in general, if your group starts with a negative, you're probably going to pull out a negative as your GCF. Not always, but for just about everything that we'll see. And then for my second term, 10 divided by negative 5 would be negative 2. My stuff in parentheses is the same. So again, I get to pull that out as my GCF, 3x minus 2. And then left over, x minus 5. So that would be my factored form. Let's take a look at just one more together. So let's take a look at this guy here. 3x to the fourth plus 15x squared plus 12. This is another problem where we have a GCF to start. So all of these terms are divisible by 3. I need to pull that out before I do anything else. Okay, so I would have x to the fourth plus 5x squared plus 4. Now we can use that AC method. So my lead coefficient here would be 1. 1 times 4 gives me 4. Factors of 4 that add to 5, well, they're looking at me right here. 1 times 4. So we're going to rewrite this as x to the fourth plus 1x squared plus 4x squared plus 4. Now, for every other problem that we did, our middle terms were just x's, right? Negative 2x plus 5x, 6x plus 1x, negative 2x and negative 15x. That's because I was replacing a middle term that was just x. Right? The idea is that I rewrite that middle term so that it would combine back to the original problem. So since my original problem has that x squared, I need to make sure I use x squared here. So just be careful with that. And now I have 4 terms, so I get to use grouping. GCF for my first group would be x squared. That would leave me with x squared plus 1 when I factor x squared out of each of those parts. And then for my second group, my GCF here would be 4. I can divide each of those evenly by 4. So for my first term, I would be left with x squared. And my second term, 4 divided by 4 would be 1. And then remember, we still have that GCF of 3 just hanging out in front here. Now my stuff in parentheses is the same, so I get to pull that out. So I would have x squared plus 1 as my GCF now. And then left over, x squared plus 4. X squared plus 4. Still with that GCF of 3 out front. Okay, and that's where we'll leave that for today. So we looked at factoring by grouping and then factoring using the AC method, which is actually just kind of a sneaky way to rewrite a problem so you can factor by grouping. Okay, so those are